And there we go. Okay. Thank you once again for joining today's session. We put another extra layer on our SQL journey, and that has been quite eventful in the last 4 to 5 sessions from now. So it's been an interesting journey so far on structured query language. And as at last session, we were able to deal with a few of the common uh, types of join. So join in the first place is the SQL statement to extract data from two different tables. Do not forget that we did mention that one unique feature of structured query language vis-a-vis relational database is the ability to pull desired data from wherever they are, even if those data you desire are resident in more than one table. You can write a query, or you can write an SQL statement to go into those different tables and pull out that information in a single table as outcome. And one of the powerful statements or code used by SQL to implement this is join, what we call join. So we did mention we could have an inner join, we could have a left join, we could have a right join, and we could have a full outer join. And we described them with what we are used to in terms of a Venn diagram showing how one or two sets interact. It could be uh, just a slight intersection between the two sets. It can be a combination of the entire thing, just like this full outer join, the combination of all the elements in the two set in this table, in the two tables, or more than two tables that are in question. And it could just be a right join, just the full part of the table B and the point of intersection with the second table. And it could be a left join, which is the opposite of right join. So today we just want to quickly finish up um, our discussion on types of join. And the one we couldn't take last section is natural join. So for natural join, we will just quickly take that. Then we see if we have one or two questions to deal with. Then we can take the rest of the time for us to practice and get our hands as detailed as possible. So just by way of reminder and refreshing our understanding, and to show how easy SQL environment is, which is more like you are using the natural language, the natural human language we are currently using. So in this case, say English. So that is how easy SQL is. It's more like you are using the normal words we are familiar with in the language called English, and only that there are selected ones that mean something important to the programming language called SQL, and you use them carefully. And that is why one of the best practice for writing SQL statements is to ensure that when you call an SQL statement, or when you write an SQL statement, you are expected to put it in uppercase. And you can see like an example of that on the screen. So all those words you see in uppercase, they are deliberately written as uppercase. It's not because if I write them in lowercase, the code will not run. No, it will still run. But it is a best practice to ensure that when you know that the word you are writing is a unique, or is unique to SQL as a language, the moment you trigger it, it is being interpreted somehow differently by SQL. So we put it in uppercase just to make our code writing as legible as possible and as professional as possible, and differentiate that from every other thing you are putting in the code. So that is why we do that. And I quickly want to brush up on few things. I made a mistake uh, short while ago before starting. I was trying to call a table and I forgot to first ensure on which database I was. So as I wrote the code for the table, I got an error message. Yes, thank God, the error message is still here. If you look down here on this lower window here, where indication of whatever you have done is written, you can see one painted in red. So that was the very first code I ran, which was an error. And I knew I wrote it correctly, but why did it return an error? So I had to check. On checking right and left, I couldn't even discover on time what exactly was the issue until it just occurred to me that, oh, probably I was not even in the right database and I'm writing a code querying some tables that belong to a different database. So because I am not in the right database, it will not run it. And what error message was it giving me? I could see that error code 1146 table word.bike_sales doesn't exist. So I could understand bike_sales is the name of one of the tables I was trying to query. But bringing word.bike_sales, I couldn't get to know, I mean, understand where the word was coming from because there is nothing in the database I was using that has to do with word. So that was when it dawned on me, oh, maybe I was in a different database entirely and I was trying to fetch a table that was not resident in that particular database. And that database has to do with word. So that is why it couldn't run. So what I'm trying to say is I want to quickly refresh our mind again. When you open your SQL environment, the first thing you want to do is to check to tell SQL to show you the database. So if you have all of that, you quickly figure out, okay, where are the database? Oh, this is it. This. And you now see the very last one here is word. That is the word that was repeating itself here in the error message, word.bike_sales. So I was in the database called Word, and I was querying some table that were never created on the database called Word. So that was why that error came in. So just to show to us some common errors we can normally run into while writing SQL. But the truth is, the moment you see the error, you just read it. Reading it will give you an idea of where the issue has occurred, and you start figuring out what could it have been, then how do you redress it, then you go back into it. So in this case now, I quickly sensed that I was in the wrong database. So what did I do then? I had to go straight and say, okay, um, go back to the database that contains the table that I want to retrieve data from. And that was while I used this. I use I said use school_demo. Don't forget, if you check this table here, showing, I mean, if you check this database, you can see the top subject is database, the list of database here. You will see that one of them is called school_demo, and this is it here. So when I now said use school_demo, I have now specified that, okay, don't go to the default database again. Go to this particular database instead. In this case, school_demo. That is the database containing the table that I made reference to in the query that I wrote earlier, which returned error. So now that I have specified the right database, if I reissue or rerun that same SQL code or statement, it will definitely give me an output corresponding to the elements specified in the code, and I can see it being projected out straight away. So let's quickly demonstrate that again. So by the time I now say use school. I've done it before, but just to do it again by way of demonstration for you. So use school underscore demo. Yeah, so it's already in there. That's fine. Then if I now say on this school underscore demo, show tables. So it's showing me the tables now. I have a table called bike underscore models. I have another table called bike underscore sales. I have a table called mules. I have a table called shapes. I have a table called students. I have a table called teachers. So for somebody just joining, you may be wondering, how did this table come about and how do you know where are they? So it's already specifying to you in this heading that tables in school underscore demo. What it's saying is that table is a subset of a database, and the name of the database we are in currently is school underscore demo. And these are the list of tables that are in there. So what can I do? I can say, okay, let's be sure that I can actually have access to any of these particular table. So do not forget, I said the most important SQL statement is select. That select, in fact, is the most commonly used SQL query or command or statement. You cannot do without it. It helps you move around a lot, and there is hardly any SQL statement that has to do with retrieving something from a table that you will not use select. And SQL statement is about being able to get data out of tables. So it means that you can hardly be able to use SQL to pull out data without picking select. So select is your go-to guy. All right. So I want to say, okay, let me see all the columns, all the different attributes. Attribute also means column. All the different attributes in one of these tables listed here. So let me say select all the columns instead of me trying to figure out what are the names of the columns in this table. I will now be trying to rack my brain. Does he have a column for ID? Does he have a column for order? Does he have a column for these or that? I don't need to do that. I can just ask it to give me the table straight away, listing all of the column. And the code in SQL for all is this star. So if I say select star, what I've just instructed SQL is that select all the columns, meaning all the attributes. Select all, then I have to say, where are you selecting all from? Then I'll mention from, and now mention the table name. So in this case, let's check a table called shapes. Then don't forget, when you are done writing that, you have to put a semicolon to end that SQL statement, and you can highlight it this way and run it. So the moment you run it, it will go ahead and fetch you the table. This is the table called shapes, and these are all the columns embedded or all the columns available in that table called shapes. Simple. Same way, I can repeat it as that. Okay, I have a list of tables given to me the other time. Okay, instead of giving me that of shapes, I think I have another one for meals. I can bring this out this way. Yes, this is a table for meals. This one has ID, meal ID column, meal name column, meal type, price, then meal days. So I can change as easily as this. That is how very easy to approach SQL. So I can say, okay, what other table did he bring out for me the other time? Um, I have shapes, I have meals, I have teachers. I will just select this, run this. This is another table for teachers. ID column, name column, experience column, designation column. Okay, I can equally go ahead and say, okay, I have another table called student. Yep, this is the table for student. Which other table did they bring out for me? Okay. So I think it was bike underscore sales. Let's run that to see what is pulling out. Yep. it brings it out. This is bike underscore sales table. I can also go to another table so easily. I don't need to rewrite the entire code again. I can just change something in there into another table's name. Okay, this one is even bike underscore models. Yes, because those are the two tables I created for that for bike data. So I can also run this. It gives me this ID model, color option, then cost. What other table? Just like that. So these are the different way you can easily interact with your tables, see what is projecting in there. So do not forget, in the last section, we are trying to see how we can pull out data from just more than one table now, and we establish some rules that SQL follows. And in that was where we discussed the four different types of joins, because joins helps us to combine uh, query to pull out data from more than one table. So you are joining one table to another, and you are pulling out data from both of them at the same time. But what happens is you must be able to establish you must be able to establish um, where you have the point of connection, and that was a secondary method of pulling out or extracting data from more than one table. The very first one, which we practiced the other session before last session, was the use of primary key and foreign key. Do not forget, we have already explained that primary keys and foreign keys go hand in hand. Those are the different keys that help us to be able to pull out or extract data from more than one table at the same time. So what we mean by primary key is a particular column in table A that also exists in table B. Though in table A, it takes the name of a primary key, that same column, if it reflects in table B, it is same column, but it will no longer be called primary key. It is now called foreign key, because it is the name of a particular column in a different table, maybe table across the ocean. When you bring something in across the ocean from another country, it becomes foreign to you. So if you bring a column name from another table into another table, that column name, even though you are writing it the same way, it is now foreign to this new table, even though it is primary to the original table. So those are the 2 points of connection when you now intend to pull out data from the two tables. That is the point of connection, because you will now link those two columns together to be able to pull to be able to pull data out from other columns from the two tables. That was the default. So apart from that, as at last session, we now move to the point where we said, okay, instead of using primary and foreign key, you may necessarily do not have a foreign and primary key connection between a couple of tables that you want to pull out data from. Take, for instance, it does not occur to the designer of the table to put in the schema. Don't forget, the schema is the structure of a table and how you have specified the different data types that each column of the table must take. And the schema also specify if a particular column is to be regarded as primary key. So from the point of creating the table, the column is already mentioned as a primary key. Let me show us an example where that is specified that a table is primary. Yes, when I created this table called bike underscore model, you can see the very first column that I call ID. That column I say, okay, let this first column be ID, then let the data type be an integer, then make it a primary key. So here I have already specified this column called ID as a primary key, and I've also specified that the type of data that must be entered into that column must be an integer. If you go ahead and impute a decimal number inside that column, SQL will not accept it. That table will never be saved. That impute will not go, because in the original creation of that table, the column called ID has been set to primary key, and the type of data that can be entered by any data entry clerk or officer must be an integer. Any failure for that input to be an integer, the system will not, will not accept it, because it is going against the schema, the originally pre-designed configuration for that table is already being violated, so it should not take it. So here it is specified as primary key. So even though another thing one could have done while specifying a primary key is to also make that primary key to be self-generating, such that when people are imputing data, they don't need to start listing the primary key table again. It will auto-generate by itself. They can list input for every other table, but the moment you want to impute another entry, that entry automatically takes an auto-generated number, which is an ID number unique to that particular record or observation. So it's always good to also specify that for some sensitive data set that you want to do. But whether or not you specify it, just like in this table, it wasn't specified. So it doesn't mean the table will not wait to work, but somebody will now need to be manually imputing the ID number for every entry that they are putting in. Whereas you could have allowed the system to self-generate or auto-generate the ID number by itself. All you need to do is to impute the data for other columns. But for that particular ID column, you don't need to be disturbing yourself, except if it is in a unique form that probably the system cannot be able to auto-generate by itself. Although if it is trained or specified further, it can auto-generate. But it depends on whoever is doing it. So that is how we use primary key. So this primary key being ID here now, if in another table, there is also a column called ID, just as it is here, then this ID becomes a foreign key in that new table, even though it is a primary key right here. An example, let me see, is there any other table that I have? This is one. Any ID here? Okay, this is customer ID. Okay, trans ID. So it is labeled differently. So this one is transaction ID. That one is simply spelled as ID, but that's how to specify primary key as it were. Yes, in this case now you can see this one goes further to say auto increment. That is the auto generation I meant. In this case, this table, regardless of the number of new entries, anybody that is authorized to populate the data set inside that database, regardless of the number they are imputing, the system will be auto-generating the ID by itself, because it is already set to auto-increment right from when the table is being created. So that's exactly what happened here. So for the second layer, where we don't necessarily need to use the connection via primary key and foreign key, you could also go ahead to look for a common, you just look for a particular column that is common to both tables. In the first one, which was default, the point of connection is always on the primary key column, which is always an ID column. More often than not, when you see a data set, the very first beginning, if the data set has a serial number, column one can be the serial number, even though we don't use serial number when you want to start extracting data from two tables. but some data can just contain serial number, no problem. The next thing after that serial number, more often than not, is going to be an ID column, because that ID column is the anchor column that is making each observation and record in the data set to be unique. So in that case, if you now have that same ID column similar to, being repeated in another table, then that ID column becomes a foreign column or a foreign key in that other table. So that is the point of connection between the two tables. If I need to extract any data from the two tables, that is the default. But aside that method of connection via primary and foreign key, you can also extract data from two different tables that do not necessarily have primary and foreign key combination. So what I'm saying is that, okay, if there are two tables that I need to extract data, there is a data that I need, and these are the two tables that can give me. I never envisaged it before. So while I was creating the two tables, I didn't set any primary and foreign key in between them. So they do not have any point of connection. But now I need to extract information from both of them. Will I now delete the table or drop the table, then go and start creating another one? That's a long thing. You can still use the table, even though they do not have an existing primary and foreign key connection. How? You can look into the table, and if you are lucky, if you see any other column that is common to both tables, then that common column to the two tables can also serve as a point of connection that can now help you to retrieve other forms of data from the two tables. So even though there is no primary foreign key combination existing, because both tables were not designed that way, because there was no intention to bring data from both of them originally, but something just came up all of a sudden in the middle of the whole analysis, and you are seeing that these two tables also need to be having handshake. Unfortunately, there is nothing connecting them. There is no primary, there is no foreign key. Okay, let's check into the table. Let's look at all the columns. Is there any column that is common to both? If yes, that's it. You can now use that column that is common to both of them. Now, in this case, we have ID for bike underscore models. That's a column. We have model as a column. We have color underscore option as a column. And we have costs as a column. Let's check the sister table. The sister table that I want to check is bike underscore sales. Let me see if it will have something in common to this table. Don't forget, this one has ID, model, color underscore option, and cost. Let's see what this other one has. ID, model, color underscore option, then cost. Now, this one has trans ID, which is different from that ID. So both of them cannot even link on ID level. This one also has cost ID. It's even different from ordinary ID that the other one has. They cannot link. Model, yes, that one also has model. This one also has model, and the model are written the same way. This could potentially be the point of connection between the two tables. You can see now, despite both tables do not have primary foreign key combination, there is still a chance to retrieve data from both of them accurately by establishing connection from the column that is common to both of them. In this case, model. Even though both of them has color, but the other one is color underscore option. This one is color. They are not two similar columns, so they cannot, no connection can be established on that. Then this one is sale price. The last one for the other table is cost. So the only common column to both table is model. So we can use model as the point of connection between bike underscore sales table and also bike underscore model stable. So in that case, that was why I pulled out this last session, this particular query. So I can put that one here also. which is this. So I am now going into bike underscore sales table, which has which has trans underscore ID as the first column. It also has model. It also has sales underscore price. So I have pulled out just three columns here. I pull out trans, I pull out model, I pull out sale. I left customer underscore ID, then I also left color. Then I went to model. I said you should pull out cost column from model. So I have specified the two tables. Go to bike underscore table underscore sales. They also go to inner join it with bike underscore model. Then the point of connection is now set here. That is the essence of this on. That is, connect both table on the column called model. You can see model is common to both of them. This first one I wrote is just table name. Table name and column name. The column name is model. This one also table name and column name. Column name is model. So connect them on that column called model and pull out those four columns for me as specified above. So we'll have it now. Let me run this. There you go. So we have the trans ID, model, sale price, and the costs being pulled out from two different tables. Now, this is what we established last session as another way of extracting data from two or more different tables that do not necessarily have primary key / foreign key combination. Now, another layer to that is now what we are discussing today, which has to do with natural joins. So this one is just describing the four set of joins that we did earlier, but there is something called natural joins that will not necessarily go through this long process that this other joins has gone through. See, you have listed all the columns from the two tables, and that is the first query. Select all these columns from the two tables, three from one table, one from the other table. What are the tables? I've specified the table. Bike underscore sales, joining it with bike underscore model. Those are the two tables. That's the way SQL understand the structure. Then go ahead and connect them on this column that is common to both of them. What is the column common to both of them? Model. So table column, then table column, then run. Then it gives us this. So aside this method, which is another way of pulling out data from two tables that do not have primary and foreign key combination. Another way to still pull out data, even if there seems not to be something like this, is to use what we call natural join. And that's exactly what we are discussing today, which is natural joins. All right. So for natural joins, it also takes place similar to the other four set of joins that I just explained and demonstrated on the SQL environment. So there is also one or more columns that exist between these two tables, and it has the same field name. And also, don't forget, apart from having the same field name, the data types specified for both field names that we deem similar now, or that we consider similar, the data type specification must also be similar, because that is the only way SQL can regard those two columns as similar. Then you'll be able to pull out appropriate data across the observation line, which is record now, or rows in a layman language. So, but surprisingly, the common fields may not need to be primary or foreign key, just as I've explained before. They don't actually need to be, because we are just looking for alternative way of pulling out data from two or more tables accurately in situations where there are no existing primary and foreign key combination between them. So that is why we also have these natural joins aside the other types of join, the inner join, the full outer join, the right join, and the left join. Another one we can do is to use natural join. So the natural join, uh, it has a resulting output that is same as that of the as the output of the inner join, just the same way it was pulled out, and I'll quickly demonstrate that soon. And except that the only point of difference is that it includes one instance of the common column, but for inner join it has a duplicate of the column or the instance in the join. Okay, so when we did this last session, this was what we had. It pulls it out this way. And don't forget, we have our inner join being used. Inner join this table, bike underscore models, join it with this table, bike underscore sales, pull out 3 columns from bike underscore sales, then pull out 1 column from bike underscore models. So you are establishing the point of connection on the column called model. So look at the steps. Those 4 steps are to be taken. Inner join, from, select, then on. We also specify the column on which the connection is to be established. But if you are using, what is it called? If you are using natural join, you will not undergo these long steps or steps as long as this. Just 2 or 3 steps will still fetch us same thing. So even though it will not pull out other attached columns that are not specified in the query, unlike the use of the inner join. So, and that's exactly what happens here when the natural join is used instead of the inner join. Okay, let's see what that pulls out for us. So now I have also said same thing. Select bike underscore sales trans ID column, bike underscore sales model column, bike underscore sales sale price column. Then go to another table called bike underscore models, pick the cost columns. So all these columns I've specified here, you are picking them from a table called bike underscore sales and also a table called bike underscore model. Notice that I did not specify a particular point where the joining is to be on, just like it was specified in this place. On model column in bike underscore sales and model column in bike underscore model. Here, I have already said natural join. So that natural join, we just go through the 2 tables and naturally look for the common column by itself and perform the join on that common column and still bring out these outputs as we currently have here. So for you to see that that's exactly what is going to happen, let me get rid of this outcome here so that it won't be there again. So I can say select all from bike underscore sales this way so that I can have a different output. Yes, now that it's clear it's a different output now. I can now run this other query, which is this. So let's see what is pulling out for me now. Can you see? Trans ID model sale price cost, just as if the same way we use the inner join is exactly what is also doing here. So the join has been performed on model even when it was not specified. But how do I know? Because the use of natural join has already taken care of that statement and story that join on. So this one has on, this one does not necessarily need to have on. So how many steps does this one have? 1, 2, 3. How many steps does this one have? 1, 2, 3, 4. So This one takes longer steps, 1, 2, 3, 4. This one takes shorter, which is just 3. And they both still achieve for us same outputs. So that is just a simple way to wrap up all the joins and the different ways you can pull out data from as many tables as possible, uh, whether or not they have existing primary slash foreign key combination sets while creating the tables, because it happens, things happen. You may suddenly discover that the tables that will fetch you what you need, the solution for the question asked in a particular project, those tables were not created with any similar primary or foreign key being established. Do you mean you want to now add it now or delete or drop those tables? You cannot even. I'm not sure is possible to add a primary key when a table is already in existence, because that primary key will affect the other data already being imputed because they have existing primary keys. So create a new primary key because of a new data you want to pull in will not be too easy. Maybe when another technology comes up, but for now, I'm not sure of any. And to circumvent such scenario or such situation, what we do or what can be done is to take advantage of these two other ways of pulling out data, which is the use of joins. And finally, we can also use natural join, and it will fetch us same reports as this. Do we have any observation, any questions? So I'll leave you to go practice all of this to take advantage or to get your hands dirty in the ones we have done so far. And I think hopefully by next session, we are just going to do a couple of questions on SQL queries. And I'm not sure there is still anything much again other than just using some SQL commands, asking more questions on SQL query. Then we are almost done with SQL. And we may necessarily move to Tableau, which is now going to give us another set of dashboard projects, um, in addition to the ones we've already done before. What other? Yes, like this particular project and a couple of other ones we did. So we did this using Excel. We are going to do something similar to this and more powerful this time around using Tableau. So do I have any question? Um, okay. For tables which were not created with both primary and foreign keys, this is a question, please. For tables which were not created with both primary and foreign keys, or there isn't common column, okay, and data is to be extracted from the tables. How do we go about this without necessarily having to go back and make these conditions met? Mm. So, um, in my thinking, putting on my thinking cap now, it can be very frustrating if you get into the middle of a project, and in the middle of the project, you now realize that the data you need to answer a particular critical project question is resident in a couple of tables that do not have any existing connection, either primary and foreign key connection or similar column name and data type connection, or natural join possibility of connection, which still boils down to the use of similar column name. and data type. In that situation, it may be very, very frustrating to be considering, do I need to pull down this table? Of course, that's not the best line of action. Do I need to create another ID column for the two tables such that they both now have similar ID column, where the ID column can be primary to one of the tables, then be foreign to the other table? Now, that now makes it possible for us to have a connection because there is now primary and foreign. And we know that two tables can connect or intersect at the point of primary and foreign key combination. That may be also be difficult to have. So in my mind now and in my head, uh, what I'm thinking could be done without necessarily having to jettison the table or drop the table or creating a new ID column that will now reflect as primary here and foreign at the other side, which can affect other existing tables in the two. What I will technically do is, since I have an idea of the project now, I have an understanding of the project very well. What I will then do is I will now create another table that will have something to do in the project. Even though it's going to look like a duplication of another table, I will consciously create a new one. I will try as much as possible to have, for that new table to have an extra feature that every other existing table does not have on that project. So at least it can also be an independent table that is serving a purpose. So while creating that new table, I will now establish a column that will be similar to the two tables that have answers to the question I want to answer. So by the time I do that, then I have creating indirectly a connection point for the two tables that I want to work on. So the moment I create that now is having a column that is similar to the other two tables. So both of them can co-occur to help me pull out something. Then the other two can also co-occur to help me pull out something. Then it may not be as easy as I'm explaining it now, but on top of my head, that is something I would like to quickly explore to solve that situation, because going back to start creating a new column that will affect existing data that you have already been working on is going to be more detrimental compared to creating a new table and trying to establish a new column that can have a connection with those two tables that are holding some vital information needed for the project to progress. So that is what I will explore in that case, which is actually a rare situation to happen. But should it happen, that is what we will do. But what I'm trying to say in essence is that it is practically impossible to pull out data from two tables if there is no point of connection at all. The connection could either be primary foreign key connection, common column connection, or whatever, but there must just be an establishment of something similar before you can pull out data, because it's not just about pulling out data, it's about pulling out accurate records that correspond to each observation in each of the data. And that's exactly what I would do in that wise. Yes, does that answer your question, Taiwo? Okay, thank you. That's fine. Any other question? Good. In the absence of none, please, I encourage us to go ahead from here, keep practicing, keep asking questions, keep exploring, and keep applying. We will give out more details as to other things in plan regarding the discovery for people managers and all sort of stuffs you can readily do with data right at your workplace and even beyond. So on that note, we draw the curtain for today's session. See you again next week. same time for another interesting and inspiring session. Thank you for your time and bye for now.